And yes, here we are. We're looking at a photograph, and I'm hoping that you've put some answers in the chat box about where, when, and who took this photo. So do we have any questions there or answers there, please?
Someone has put Neil Armstrong as an answer. The photo is from the surface of the moon.
Right, that is good. It is actually, yes, the surface of the moon. And what is the other planet of?
It's the Earth from the moon.
Excellent, thank you. So this photograph is called Earthrise, and I thought it was very apt to begin the webinar this afternoon with this photograph. In fact, it wasn't Neil Armstrong that took the photograph. It was taken just a short while before by William Anders in 1968 when he was in Apollo 8. And when it was orbiting the moon. So it actually was before Neil Armstrong walked on the moon. But it's a really good photograph to get your learners excited about the moon and also the Earth rising above it. So let's look now at the outcomes or the aims of this webinar today. What are they? Right. Today we're going to be introducing Earth and space at primary level. You're going to explore the new content of Earth and space from the new Cambridge International Primary Science Curriculum, which is now called 0097. We're also going to give you plenty of ideas on how you can inspire your learners as they progress up through the curriculum. And also, I'd like you to be sharing the ideas that you may already have for teaching the Earth and space strand. We're also going to have the opportunity to have your questions answered during a live panel discussion where I'll be joined by Rob Thompson, who is the International Sales Director for HarperCollins. So, before we get started, we're going to do a little activity that I often do with my learners when I am trying to find out where they are with their learning. And I call this activity 3, 2, 1. We've got liftoff. So in the chat box, please could you write down now as quickly as possible 3 things you know already about this new content strand. Please don't feel shy here. Write down the answers, and then perhaps if you do feel a bit shy, you can just write them down on a piece of paper. I'm not testing your knowledge here about Earth and space.
Some people have said, no idea.
I think there's a sense of humour there. Because we're not rocket scientists here. Okay. What do you think?
Solar system.
Excellent. Yes. Now we're going to get you running.
Planets.
Okay.
Cycles of Earth.
Brilliant. Cycles of Earth.
Orbits.
Orbits. Yes.
Planets and galaxies.
Excellent. Okay.
And spaceships. It looks like everyone's more or less on the same wavelength.
Yeah, it's a great new exciting new strand. Okay, and we are going to go through the some of the learning objectives in this new content strand during this webinar. So if I actually went off and said what they all are now, we'd be losing the thread of the webinar. So now what I want you to do is to think of 2 challenges you think that you will face when you're teaching this new content strand for Earth and space. And if you could write some answers into the chat box, that'd be great.
The language and the practical work.
Excellent. Now, this is exactly what the webinar will be addressing. Okay.
Questions that never stop from students.
Lovely. Okay. And that is a really good answer there, because this is exactly what we want to be doing, is to develop those inquiring minds of those students, and also to actually be honest with them. If you don't know the answer, you can say, well, we can look it up, you can look it up, or we'll come back to you. And sometimes there might not be a right answer, but we want to develop those inquiring minds of those learners.
Yeah.
Any more?
There are quite a few. So some people are saying it might be difficult to demonstrate. Getting students to explore it practically in an online platform might be difficult.
Yep, that's great. We're going to give you a few ideas during this webinar.
Ways of making it easy and interesting might be a challenge.
Yes, we're going to give you again a few more ideas here. I think this is great. When somebody said earlier about no idea, and that's like you're thinking, oh my goodness, it's lack of specialist knowledge here. I'd say, hold on here, okay, because I will be giving you some support. The next thing is, if you could just write in the chat box one takeaway that you would like from this webinar. And it might be a certificate, which, as Charlene has said, you will be getting.
Some people have put new methods of teaching, strategies,
lovely
techniques.
Lovely. Okay.
Practical resources, please.
Okay, right. Hold on there then. We'll be giving you some ideas. And also, if we haven't given you enough ideas, we'll be giving you some links on how you can explore even more. Okay, so let's go on to the next slide here. And firstly, I'm going to start off with a word of reassurance. Don't panic, okay? You don't need to be a rocket scientist to teach this new content strand. You don't need the most fancy equipment to be able to look out at the stars and beyond. It's all going to be very accessible for you and your learners. Now, some of the content area for Earth and Science will be familiar to you. There are some learning objectives already in different topic areas in the current science framework, and some of these objectives have been moved to the new Earth and Space content strand. Some have been moved over from other stages, from both primary and lower secondary. And of course, there are some completely new learning objectives too, but that's not to say it's never ever been taught before. It would have been taught in some different areas of a curriculum or your local curriculum. It's just dependent on the context. The rationale for doing so is to create a foundation for greater progression for learners going from primary up to lower secondary, and then to be able to access IGCSE. We've also thought, or Cambridge International have actually thought about science in the local context, as well as being aware that learners need to be prepared to enter that global stage. And that's why here with the HarperCollins resources, we've actually borne that in mind with creating content that will be familiar to your learners in your context, but also preparing them to enter the global market and equipping them with the right language strategies to be able to do so. There's one word of caution I'd like to say, and that is that the learning objectives in the new curriculum may have prior learning requirements, and learners will not necessarily have experienced this in the current curriculum that is being taught. But this is where the guidance in the teacher guide can help you. And the guidance can also help you in the teacher guide address certain misconceptions, such as the Earth is completely flat. Also, if you are a Cambridge International registered school, you can actually access the website there, the School Support Hub, and you can get hold of progression and transition grids, and that will help you map out your scheme of work, which will suit you. So let's now look at actually what these new, what the new substrands are for Earth and space. So what do you think we're going to be looking at? I won't ask you to write the answers in the chat box here, because I'm going to just tell you, because we've got the 3 pictures coming up, okay, and they are going to tell you what the 3 separate content strands or substrands are for Earth and space. So the strand is going to cover the study of the planet Earth. It's also going to cover the wider solar system and beyond. Learners are going to develop an understanding between connections between land, oceans, and the atmosphere, and then the life of our planet. They're going to investigate how the key cycles that shape our planet Earth are closely linked with the solar system. And also they're going to learn about the formation of Earth, the geology, and the climate. So let's look now at the first substrand. And we're going to be starting off with what is close to us, planet Earth. I'm going to summarize the key topics for you here, but I'm going to highlight that not every stage always covers that topic. And there is a rationale from Cambridge, and that is the fact that there is so much content to cover that it's not always felt appropriate to add it in at every stage. So for planet Earth, learners are going to look at different types of rock in the lower stages, whilst at the higher stages, they will classify the different types of rock, such as metamorphic, igneous, and sedimentary. They'll also discover that many useful materials, such as oil, natural gas, and metals, are found in rocks, as well as describing the way that fossils can form in sedimentary rocks. Now, this is what I find really exciting about this particular substrand. We're going to be raising learner awareness on issues such as pollution and how it's caused. We also begin to look at the structure of the Earth and volcanoes and earthquakes. So you can see here from the graphics that you've got in front of you is that we really do engage the learners with questioning what the effects of pollution or even earthquakes and volcanoes can do to our land. So the next substrand, cycles on Earth. Now, before we actually give you the answers, could you tell me what 2 cycles you think they might be on Earth?
The water cycle.
Fantastic, thank you.
Someone has put the carbon cycle.
Carbon cycle, not quite here at the moment.
The rock cycle.
Lovely, okay. In fact, I should have framed that question a bit better. At primary level, we only look at 2 cycles on Earth. And that is, as Charlene said, or you have said to me here, it's just the water cycle and the rock cycle. And we only look at them at stages 5 and 6. So this is our smallest substrand for Earth and space at primary level. So next we'll look at the largest substrand, and that is space. Okay, now this substrand is not just about naming the planets in the solar system. There's so much more to it than that. At the lower stages, learners find out that the Earth is the planet where they live, or that the sun is a source of heat, or the differences between night and day. Learners also find out how the tilt of the Earth can create different seasons in different places, or the relative movement of the Earth and Moon, as well as finding out about exciting things, like you have already said, about asteroids and comets. This knowledge is built upon progressively during the years at primary. So I've just given you a whistle-stop tour about the content of Earth and space in this new and exciting strand. What I'd like to do now with you is for you to be using the chat box, and for you just to tell me what were the other two strands. Okay, we've got planet Earth already up here. And what are the other two substrands for Earth and space? The answers are almost given away there by my question.
Cycles on Earth.
Lovely. Okay.
Environmental issues.
Yes, then that would. Sorry.
Space, life in space.
Life in space, yes. Yes, space, Earth in space, it's called. That's lovely. Cycles on Earth, Earth in space. Environmental issues would come within the substrand of planet Earth. Now I've got an exciting tool that I can just show you that you can use at the end of a class, or you could use at the beginning. It's called the random wheel, or the Wheel of Fortune, and you can access this resource from WordWall. Here I've created my own. You can actually access pre-generated resources which could fit in within the Earth and space substrand. But here you can see I have actually labeled some substrands, and I would click on spin it, and it would go around making this fantastic whirring sound, and then it would stop at an arrow. So here you can see that it's stopped at know the movement of the sun during the day. And what I'd like you to do now is to put into the chat box, okay, which substrand that would be.
We do have a teacher here that says that they use WordWall often.
Excellent. Okay, that's great for sharing. And in fact, if that teacher could actually say whether they actually generate their own resources or whether they take actually pre-generated resources made by other teachers. There is a fantastic idea here that you could be doing, is like you could be creating your own forum of teaching Earth and space from Collins International, and actually create your own resources or starter or plenary ideas.
So someone has said the motion of the sun falls in the Earth in space strand.
Thank you. Okay, and so if you were playing a game with your learners, you say 1 point to you, okay?
Also, the teacher has come back and said they use both their own resources and those from the net.
Fantastic. Okay. Sometimes you have to be careful with using pre-generated resources because they might not necessarily be tailor-made to the lesson you're actually teaching. But it is a great thing that you can be using in the online environment with your learners. Today, due to time commitments or pressures, we're not able to actually flip between the two screens. But it is a great engaging tool. I will just do one more here with you, pretending that I'm actually turning the wheel, okay, and my wheel stops at, okay, describe and compare different types of rock. Which substrand would it be? Would it be planet Earth, cycles on Earth, or Earth in space?
Planet Earth or cycles. There's a mix, it seems.
Interesting, yeah, and we will come on to this in a bit. Actually, it is, this particular learning objective is from planet Earth, but you can see how you do need to know the different types of rock for the rock cycle, which is cycles on Earth substrand. And you will see in a moment how Collins Resources have very cleverly combined those two learning objectives, even though they're from two different substrands. So let's go on to thinking about teaching ideas for Earth and space. And what I want to do here is to start by making a point. I've been really lucky in the last few years to have been able to go into primary schools internationally, as well as in the UK, and to see how teachers interpret the teaching or the learning objective of the different planets and how they've exploited it. I'm going to ask you a closed question here. Is this a good way of what you can see up here on the screen with the teacher standing by the board and saying, find out about the planet Mars and make a presentation? And then we have our dear little learner going off with a pile of books and coming back with this. Mars is the fourth planet from the sun in our solar system. It's the second smallest planet in the solar, blah, blah, blah. Yes or no? Is it a good idea? Oh, right, that's great. Okay, thank you. I'm not going to say why not, okay, because I think you would know that I'm doing this or place this slide up here as a warning, okay, because this kind of project work, it does have value, but it can result in the following. It can result in children spending hours on the internet or in the library, lifting information that they don't understand and then reading it out aloud in the form of a presentation, and no one is really any the wiser. I want to say, yes, there is value in doing research projects, but is this really science? What we need to do is to ensure that we create a balance between getting children involved with hands-on practical activities, along with equipping them with the research skills to explore secondary resources independently. Because at the end of the day, we want to be creating that resourceful, independent learner. Now, for the next part of the webinar, we'll be looking at different and interactive ways of exploring the teaching of Earth and space. Okay, so let's move on. And here, we are looking first of all at the first substrand for planet Earth. Okay, now this particular learning objective, describe land as being made of rock and soil, that's down at stage 1. Just like to introduce the information that you've got here in front of you, and just to say it's the 4th lesson in the unit when the learners are discovering that they live on planet Earth, or that where they live, the planet they live on is called Earth, and they've also, prior to this, been finding out about the fact that Earth is covered in water, and then now they're thinking about the land, okay? After ensuring learners understand that the land on Earth is made up of rocks and soil, we can do this by looking at the pictures in the book, or by actually showcasing or having pieces of rock in the classroom for them to be looking at, or if that is difficult, to get videos as well. And we have got those resources marked up in the teacher guide. I would also do some hands-on sorting and classifying different types of rock. Again, guidance is given to me that I can actually do this in many different ways in the classroom or outside in the playground by using hoops, or even putting stones in touchy-feely bags and getting them to see if they could feel the different properties of those stones. Now, in our resource here, if you see on the next slide, we have got photographs of our children classifying the rocks, looking through the rocks in the classroom with magnifying glasses. You've also got them looking through magnifying glasses with the soil or at the soil. And then we've got a lovely worksheet to accompany this, whereby they are drawing a picture of their rock. You could be asking them to draw a picture of a rock that they bring in from home. Now, if we're teaching our learners at home, obviously we're going to be approaching it differently. But you can still try out these ideas. You can say to them, go and see if you can find 3 different types of rock. You can also go and ask them to get some soil. Obviously, you'll need to actually set up the health and safety guidance with them as well, in explaining to the parents. But I'd like to know from you if you have got any other ideas that you could be using at this young stage for teaching rocks and soil.
So some people have put the example you said, which is to collect stones and classify them at home. Looking at the texture of the soil.
Yep.
Going to the beach and exploring the different types of rocks. If you have a beach, that's lovely.
Yeah, that's great. Yeah, I mean, that's a prime example. We've got lots of ideas with the PowerPoints in the teacher guide. Now, just remember that we are actually at stage 1, so it is very much hands-on and learning about what they've got in front of them. Let's move on to the next slide. And here, I've chosen this particular learning objective here because it is new to the Cambridge International Curriculum, and this is in stage 5, and it's the actual learning objective is finding out about the fact that the Earth is surrounded by a layer of air which is called the atmosphere, and that's a mixture of different gases. Now, here we're not just learning about the different gases or getting our learners, as you can see here, to tell us the percentage of each of these different gases found in the atmosphere, but also we're raising awareness of the greenhouse effect and global warming. And it's exactly as somebody suggested right early on in the presentation about the fact that we're raising our learner awareness about environmental issues on Earth. Now, this is what is suggested here in the student book. and in the teacher guide. But what would you do if you were teaching the Earth's atmosphere online? How would you approach it?
We got some great examples from the other question as well that came through just a little bit too late.
Okay, I'd like to hear it.
Some people for the other activities said doing a garden treasure hunt with painted rocks.
Very good idea.
Mm-hmm.
Yeah.
And also someone commented that they're not sure how to get the students to go outside because they live in quite a hot environment. There's a few things that have come through for the atmosphere. So maybe ask students to use Play-Doh to represent the layers of the atmosphere.
That is great. Yes. Different colours of Play-Doh.
Mm-hmm. Using cotton, maybe.
Mm-hmm. And this is great because it's bringing in another content strand, and that is making models or thinking and working scientifically. So that is great. So yes, we've got ideas here for making models. So we're taking that learning just a bit further so that they can understand about the different gases making up. Let's move on here to the to another substrand, and that is cycles on Earth. Now, as I said earlier, it's the smallest substrand. We introduce it at stage 5, and it's a fairly straightforward standard textbook diagram that we've got here. What I'm interested in, though, is how can we make it more active for children? Yes, we could make a model for them. You could make or get them to make a 3D model, and they will have great fun and they can actually make that at home by themselves. But there are other ideas too. And I'm just wondering if you have, whoops, no, sorry, you can't see it yet. If you have got those ideas too. Answers in the chat box.
Right,
So the next slide.
Or let them draw and paint.
Nice.
Making a diagram of or a 3D form on the water cycle.
Lovely.
A working model, maybe.
Yes, a working model. That will take some thought, and that I think that is perfect. I've got an example here on the next slide of a working model, really, or an experiment, and it's very hands-on. All you need is a plastic bag and perhaps a marker pen. You could have some blue food colouring and some water. And really what you do here is such a simple, fun activity, and they can do this at home by themselves, is you would ask them to draw the cloud and the sun and the seawater on the plastic bag. Then you'd ask them to fill it up or up to the wave level. And if they've got blue colouring, please put it in. And then you just ask them to hang that bag with some sticky tape on or in front of a sunny window for a few hours. And then after several hours, go back to look at the bag, and there you will see heavy condensation appearing on the bag. And you would get them to actually observe, either if you've got a live lesson going on at home, or to get them to write down. This is an idea that is in the teacher guide. You would tap the bag and, if necessary, make water droplets fall. This experiment is brilliant because it allows students to observe the water from the bag evaporating, condensing and falling like precipitation or rain, and then also collecting again at the bottom. And what I like about using the blue colouring is that the blue colouring is heavier than water. And so after a while, it separates, just like salt falls to the bottom of the ocean. So that is a lovely hands-on activity. I've got another type of activity for teaching the teaching the rock cycle as well, which is less of a practical hands-on, but it's got more of a digital aspect to it. So this particular substrand or learning objective, the cycles on Earth, describing the rock cycle and the formation of metamorphic, igneous and sedimentary rocks, is in stage 6. Again, it's fairly straightforward. It's something that you would find in the in a standard textbook. Here, I love the graphics because they're exceedingly clear. And it's a completely new learning objective for the Cambridge International Curriculum. So we've got some very clear guidance given to us how we can introduce the rock cycle. Yes, they can be making models, but you could also be doing a drag and drop exercise, an interactive exercise. You could use the examples that you can see here from WordWall. You could create your own as well, but you could do a drag and drop. You can do answers against the clock, either between you and the learners or learners between themselves or individually, and get them to submit the time that it took them to get it right. So that is a way that you can do it in the digital online classroom. Another way you could do it, which is a really fun and yummy idea, is that you could go away and get them to make their own edible rock cake. Now you can get ideas and recipes by going online and just typing in edible rock cycle ideas, and you will come up with a whole host of recipes or diagrams. You could even get them to make their own recipe. This works very well for the home learning. You could also introduce it in the classroom, bearing in mind the health and safety and allergies that learners may be suffering from. So that is another great idea. Now, I'm going to just show you on the next slide how Collins have actually combined the teaching of 2 different substrands within one particular topic or unit. So here you can see that we are introducing our learners to the fact that fossils are found within sedimentary rocks. What I really like about this is that the teaching of that previous learning objective about the cycles of rock leads on really nicely to this one from the Earth substrand. And I like this as an example of progression, and also how the teaching of one learning objective does fit in or lead on nicely to another from the same content strand. So it's really good that Collins have actually knitted together to make that unit quite cohesive for your learners, and so they do not feel that they're jumping from one learning objective to another, but they can see how they link in. So we're now going to come on to our last substrand, and that is teaching ideas for Earth in space. This particular learning objective, describing the regular change in the position and appearance of the moon, comes from stage 3. You can see here that we introduce our learners to the different cycles of the moon, and you can see that from the workbook page on the next slide. we ask learners to follow the moon for a week from their own home. So you can see that it's activity based. They're actually engaging with the content of the student book and processing that content to make it relevant to them. Okay, so they're discovering science for themselves. They're asked to draw the moon accurately, and you can see that a learner has done this on the right hand side here. And they're going to interpret that drawing to understand not just the cycles, but to understand the concepts of waxing and waning. So here they're marrying up the content of the student book with their own learning. And that is a really great practical activity, which just demonstrates that you don't need fancy equipment to be able to carry out experiments with your learners or investigations with your learners. Now, we did mention earlier about teaching science and the content or the language that is involved with teaching science, especially if you've got a second language learner. Now, one of the great things about the resources that we've got with us today with HarperCollins is that at the back of each student book, there's a glossary. And we can do some great language games with our learners to ensure that they've actually understood not just the key term, but also the actual definition as well. This is one of my favorites, and I'm sure that you've come across it too, about playing bingo. But I use it to test their understanding. And it works really well with my second language learners. So on the next slide, I do have the keywords. And what you're asked to do here, or your learners are asked to do, is to actually select 9 keywords and to write it in their grids. And you can do this online. You could actually share your screen with them and do the 9 keywords by getting them to feed in the keywords, or you could be giving them screen share and getting them to write in 9 keywords, or they could just be writing it on a piece of paper and hold up their keywords to the screen. So I think we might have some time left here. Oh, we've got 20 seconds left. We have got 20, right?
Let's have a go. Let's have a go at bingo.
Right. Okay, so we're not going to write down, you're not going to write down 9 keywords. What I'm going to get you to do is, by using the chat box, okay, is that I am going to give you the definition. You're going to give me the keyword. So we're assuming here that you've written these keywords down. Okay, so please use the chat box. What keyword is this? There are 12 of them.
Planets.
Thank you, right. Well.
Or months as well.
Or months, okay. Right, okay, we'll get a better description for that because, okay, I will come back to one of those in a moment. Next one is parts of the Earth above and below the equator.
The hemispheres.
Lovely, thank you. Okay, right. The curved path through which objects in space move around a planet.
Orbit.
Lovely. Okay, last definition. An extremely large, round mass of rock and metal, such as Earth, or of gas, such as Jupiter, that moves in a circular path around the sun.
Ooh.
or around another star.
Rocky planet, gas giant.
That's a bit of a, yeah.
Asteroid.
Rocky planet is closest, but I would go for
planet.
Planet, yeah, I would go for the planet. And okay, now the number of planets, okay, is up for discussion. Okay, so I mean, we could leave the actual content of this webinar now for you discussing how many planets there are, because I don't think it's necessarily been agreed with some planets might not be real planets. Okay, I suggest you go on to NASA, or I'm going to look here now on my next slide.
They're all saying 8. They're very adamant that it's just
okay,
8,
and there's
some dwarf planets.
Yes, there are. Yeah, that's correct. And we have to be very careful with navigating the content regarding planets and teaching of planets. HarperCollins does look at that with sensitivity, actually, and will give some suggestions. Also, you could look at the NASA website, which you can see here, for further resources, and that will give you more guidance for the teaching of planets, as well as the European Space Agency. We've got here in the UK an organisation called STEM, and that will give you some great resources which are actually categorized by substrand. I would like to just highlight with you that some of these resources may not be mapped to the Cambridge International curriculum, nor may they be directly endorsed or not endorsed by Cambridge International. Okay, we also have BBC Bite Size, which is fantastic at the moment, for especially when schools are shut. I came across a great video for teaching planets, or the order of the planets, and they've got some stories as well. Also, actually, within the Collins resources, within the teacher guide, we do have some great big cat stories which link up as well with the teaching of the different learning objectives. And so those are highlighted for you. And I would just like to say that if you are a Cambridge registered school, you can find more support on the hub there. But if you're not a Cambridge registered school, Cambridge International have put up some ideas on the public domain for support and training and ideas for when your school is closed. So please do look there for more ideas. We've only had 45 minutes today. We've covered a lot in 45 minutes. If we go back to our rocket, or our 3, 2, 1 at the very beginning, I did ask you about 2 challenges you think you would face and a takeaway that you would like, or that you have got now from this webinar. I'd like you to think, if you've still got some questions, and I sincerely hope you do, is for us to actually now have them answered with a live panel discussion. Rob Thompson is going to join me now, and we will answer your questions.
Hi everyone, thank you Siobhan for that excellent presentation, which I particularly enjoyed. Yeah, we're basically here to answer. We've got about 10 minutes. If you have questions, please put them in the Q&A. We can have a look at the chat as well, but if possible, put them in the Q&A. We do have one question which we can just refer back to, which is about the science syllabus. Do you have an example of the science syllabus? Because my school is going to start teaching science, but we don't have any syllabus and we are confused about which one we're going to use. Now, the presentation you've done today, and obviously the work that Collins have done in publishing, is all revolving around the Cambridge syllabus for primary science, which is for first teaching in September 21 this year. So that's the syllabus that we've been referring to, and Siobhan's been referring to, and anchored the presentation around. In terms of the actual detail of the syllabus, we would refer you really to go and talk to, or have a look at, the Cambridge Assessment International Education website. And they've got the details of all of their syllabuses and some more details in there as well. I don't know if there's anything that you wanted to add that I've missed there, Siobhan, but I think that's pretty much that question.
Yeah, no, that's great.
And it kind of leads on to a question that we had earlier, and is a question that I have as well, and is worth answering. This is one for you, really, Siobhan, which is about where people can see which learning objectives are entirely new.
Yeah, now that is something that in terms of those learning objectives that are entirely new, within the teacher guide, we have got the learning objectives mapped out at the beginning, but it's not necessarily highlighted which ones are entirely new. However, when you go through into the individual learning, into the individual lessons, you will be able to get a flavour of what is new by looking at the scientific background information that you're given for each lesson. But for you to actually find out which learning objectives are new, if you're a Cambridge registered school, you can go onto the CAIE website, or the school support site, and you can download progression and transition grids, and that will help you with your planning. But you can rest assured, I'd say, with the learning objectives, with the teacher guide from Collins, is that we are covering all of the curriculum. However, you will need to plan for addressing some gaps in some gaps in your learners' knowledge. I wouldn't worry too much, because we have got some learning objectives that have shifted down rather than being missed out.
Cool. And I'd actually add, there is a point in the question and answer about PowerPoint resources, and Siobhan, you've just referred to the teacher's guide, and there will be PowerPoint and resources that you'll have access to via a teacher's guide, because it's important for you to have those. So keep an eye on those as they get published, and that's where the resources and extra resources would be. There is a slightly complex question in the Q&A. I'm not entirely sure that we will be able to fully answer it, but I'm gonna read out the question, and we'll give it a bit of a challenge and see. This is from a teacher who says, we're a PYP school, so in order to not repeat the same central idea, the kindergarten won't do the earth cycles this year. We find it really difficult to teach that under another strand that is relevant and suitable to this age group. What would you advise? So teaching of earth cycles really at kindergarten, I think that is about.
You don't need to.
That's a very simple. You'd introduce that at year one, you're saying, or
no, with the earth cycles, that's one, as I said earlier, that we don't. There are only two substrands only two learning objectives within, or two or three learning objectives for earth cycles. That's the water cycle and the rock cycle, and that's not introduced until stage 5 or 6.
Okay.
So there's no.
You don't need to. That's one less thing to worry about.
Yeah.
Learning. There's an interesting question here about as a primary science coordinator, what should you do to ensure that we add on the different areas of learning rather than repeating them? And I'm guessing from our perspective, that's about making sure that you go over to the new syllabus in its entirety, rather than trying to use current lesson plans and planning and just bolt on the new objectives, because I'm assuming that there's quite a lot of different areas of learning that are intertwined that will need some careful planning.
Yeah, I mean, first of all, find out if you are a Cambridge registered school, because you do get the support there, and you will know that your books are covering those learning objectives, those new learning objectives. Yeah, you might have to be careful with, say, for example, I said the rock cycle is completely new, and as Rob has said, that your current resources may not have that. So it does make it quite messy if you're trying to match up content, old content with new content. There will be a transition period, and Cambridge International have taken this into account, and they will give you lots of guidance there on their website.
Yeah, and Cambridge are telling us, and obviously telling schools that the first teaching of this will be in September 21. That was another question that comes up. And the first assessments will be to the end of the summer term in 22. But there is a lot of work that the local Cambridge offices and Cambridge assessment people are doing to help that transition, because schools won't necessarily all transition over. And I know that I've seen some working documents and seminars and some help about different ways of transitioning to the new syllabus, but the assessments will start to change from summer 2022.
Yeah, that's correct. Yeah.
Just slightly conscious of time. I know that there's a couple of questions. I think we've answered 2 of them. And we talked about the kindergarten, say that's a totally different strand of content as well. And obviously the pre-14 syllabus does come into effect from year 1 or stage 1. So there isn't necessarily a kindergarten syllabus. There is some work that I know we and other publishers are doing in terms of trying to make sure that if you are trying to get resources at kindergarten, that they're appropriate and they lead into stage 1. And I would sort of keep your eyes out for that sort of thing turning up in the very near future, because we know that there's a lot of support needing to sort of framework and scaffold the learning at kindergarten, to make sure that if you have kindergarten and they go through to stage 1, that they've got the right background work in the practical manner. I think that's our hour up. So I can sort of end off really by thanking Siobhan again for the excellent presentation and for taking part in the Q&A, and for some real insights into these new strands. I know that they're really helpful. And also Charlene and her back office crew for both this morning's webinar and this afternoon's webinar, and helping everything go smoothly. So thank you, everyone. Thank you for coming along. We really appreciate it. And if you have any questions, our email address and contact details are on the screen, and we would absolutely love to hear from you.
Yep. Thank you very much, everyone.